After completing this chapter, you will know how an ECDIS is prepared for passage planning. Often, the initial part of passage appraisal is to confirm that there are sufficient charts for the proposed route. It could be that a vessel has folios with charts for geographical areas. If not, they would have to be obtained. One way that a vessel can do this is called Pay to Sail. Click on the button to see more about Pay to Sail. With Pay to Sail, a shipping company has a contract with a chart supplier who supplies all ENC chart cells to a vessel. However, the vessel only pays for the ones that it has an interaction with when monitoring. If chart cells have to be purchased, consult a chart catalogue to compile a list. The catalogue is possibly found on ECDIS, a standalone computer, or via an internet website. The Primar website has an easy-to-use chart catalogue, allowing compilation of the chart list. The ECDIS itself may also have the ability to compile a list of charts for a proposed route entered into it. ECDIS has a world catalogue that allows chart cells to be identified. Here we see that a request has been made for coastal charts in the area highlighted in red. Full details of the cell becomes available. This includes the edition number and any updates. Sufficient official ENC charts covering all usage bands are required for the whole voyage. If there are areas of the route not covered, then raster charts should be obtained. If there is no pre-planned route, the ECDIS can be used to browse the loaded charts. From this, some idea is obtained of such things as where there is sufficient depth of water, where there are traffic lanes, any danger areas and navigation marks. To help the appraisal, digital products can be used that give a variety of information. When appraising or monitoring, temporary and preliminary notices should always be consulted. There could be an overlay for this, such as the Admiralty Information Overlay, but some chart suppliers add T's and P's to the updated chart cells. Whilst on passage, a connected workstation allows a route to be worked on while the main ECDIS is being used to monitor the vessel. When ready, the worked-on route can then be sent via the network to all other ECDIS for local storage or use. Here are some of the advantages of using an ECDIS for preparing a passage. Electronic devices can give the operator a false sense of security, believing everything they see to be correct. For example, a previously saved route can easily and quickly be used without proper reappraisal. It looks acceptable, but without a proper check, it could be dangerous. In addition, some ECDIS display screens are small. With permits and charts loaded, set the chart display to show all information, so that relevant chart detail can be seen. The IHO base and standard displays do not have sufficient detail for passage planning. Check the stored information on the vessel, such as length, breadth, maximum turn rate and speed, and the position of the consistent common reference point. Remember, this is the reference point on the ECDIS that all ranges and bearings are based upon. Also, the heading marker, ground vector and safety detection all start at the CCRP position on the vessel symbol. Protecting the vessel from grounding is one of the main objectives of passage planning. A properly set up ECDIS can assist with this. Considerations for setting under keel clearance values include anticipated squat for the planned speed, reduction in clearance caused by pitching or rolling, reliability of the charted sounding information, and a safety factor. In addition, port authorities often stipulate a minimum under keel clearance for a vessel transiting their pilotage district. To see how much a vessel reduces under bilge clearance with rolling, click on the button. The table shows the reduction in available water under the bilge of a large vessel rolling in waves or when heeled due to wind or turning forces. There are 3 contour values that can be set that affect the color of the displayed water surface. However, the safety contour is the only one that will cause an ECDIS alert. Here we see that there are 4 depth shades with the safety contour set to 10 meters. The default value of the safety depth contour is 30 meters. It is important to set a value that reflects the draft of the vessel and the other variables. The list shows some advantages of having the correct setting for both safety depth and contour. When passage planning, if the height of tide is known, this can be allowed for in assessing the value of the safety depth and contour settings. The illustration shows a safety depth setting of 10 meters. On the chart display, all soundings less than 10 meters are now in bold. Objects with a depth attribute less than the safety depth setting show a magenta isolated danger symbol, making them more easily seen. Let's see how the value of the safety contour is calculated for a vessel with a maximum draft of 12 meters. Plus squat of 1 meter equals 13 meters. Plus a safety allowance of 15% of draft because of UKC and confidence zone on the ENC equals 14.8 meters. There is no allowance for rolling or pitching or height of tide. The calculation means that the safety contour value should be set to 14.8 meters. The ECDIS would default to 15 meters, being the closest one up from 14.8. With a 5-meter rise of tide, the safety contour could be set to 9.8 meters, with the ECDIS using 10. The text shows a summary of the calculation. There is much confusion and often misuse words representing lines on a chart and vessel movement. Hover over the hotspots to see some definitions. Here is a summary of what we have looked at in this chapter.